Hi, welcome back to Moose and Chemistry. This is titration and pH lesson number 3. Alright, I'm going to be using my favorite formula for titration, which is M1V1 equals M2V2. And I'm going to probably be using also pH and negative log of hydrated ion, or I can just use this one too. It doesn't really matter because it both works the same. And in my second problem, I'm going to be using pH plus POH equals 14. Just watch and see. Alright, so if it takes 54 milliliters of the 0.1 molarity of NaOH to neutralize 150 milliliters of HF acid, what is the concentration of HF? So let's go ahead and figure out first the titration formula. And then we need to know who our players are. Now, instead of doing your head, it's better just to write it out along the side here. I mean, it's easier to keep track of all the information. You would be so much happier to do this. So we have 54 milliliters here, 0.1 molarity there, 150 milliliters there, and we have no idea what M2 is going to be yet. So M2 isolated is M1V1 over V2. So M2 is going to be 0.1 M times 54 milliliters over 150 milliliters. Scratch that. And M2 is equal to, looks like it's going to be, let me double check with my calculator, but I think it's going to be 3.6 times 10 to the negative 2. So that's my guess. Let's see what I get. I use a calculator. I mean, using calculators are fun, but you know, sometimes they're a bit ambiguous. But in this case, it's right. It's 3.6 times 10 to the negative 2. Snarls. Okay, that's my molarity. Now, I want to know, and that's my first answer, that's my concentration, so that's the actual answer, but we're going to use pH to see if it actually worked out well. So we're going to go pH equals negative log of, I'm just use my H plus ions, why not? pH equals negative log of 3.6 times 10 to the negative 2. Yeah. So I'm going to take my calculator and I'm going to play that game and see what I get. Negative log of 3.6 exponential negative 2. And I get 1.44 for the pH. And you know what? That makes perfect sense. Because that makes this a very strong acid. And that's what HF is. HF is a very strong acid. Alright, so let's look at the next problem. If it takes 30 milliliters of the 0.15 molarity of H3PO4, which is phosphoric acid, to neutralize 500 milliliters of potassium hydroxide basic solution, what is the concentration of the KOH? Okay, so again, we're going to use our titration, M1V1, M2V2. There's another way to do it too, and it's there's another formula out there. And trust me, it's just horrible. You definitely want to do this route. This is so much nicer. And it's just as accurate. And as a matter of fact, it's a lot easier to do. It's accurate and easy. And that makes it the best possible two worlds. Okay, so we're just putting in our players right now. And we're looking for M2. So M2 equals M1V1 over V2. M2 equals 0.15. You could do this all weekend long if you wanted to. Think about all the fun you could have with your friends doing titration problems. Hey, I got this one right. What about you? You know. I don't see you would have any friends. Come on. True friends stick with you. So, okay. That cancels out. And my M2 value is going to be, of course, let's see here. Looks like about 9.0 times 10 to the negative 3 m. That's my concentration. All right, let's see if that concentration makes sense though. Okay, so before I do that, I'm gonna double check my answer with my calculator, because lately I've been having a little bit different answers. So I'm just gonna make sure everything looks good. And it absolutely does. All right, so that confirms that. All right, now we're gonna figure out the POH. So, well, I can actually do it by pH or POH, it doesn't really matter. I'm going to use POH. Why not? This guy right here equals a negative log of the OH ion, which is this character right here. So it's POH equals a negative log of 9.0 times 10 to the negative 3 m. So my POH is going to give me 2.0, but that's not my actual pH, that's the POH. So then we'll go pH plus POH equals 14, right? So then we're going to go pH plus 2.0 equals 14. pH equals 12. Check that out. That's a strong base, and KOH is a strong base solution. Well, that's it for this lesson. You guys be snarly, and we'll see you back here at Moosine Chemistry.